Okay, here we go. So law of cosines is a different thing, but it's still for the same purpose, which is we're going to learn how to solve triangles. Quiet, please. Okay, we're going to learn how to solve triangles now that are side, 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 or side, angle, side are the parts that you know, right? In both of those, if you would just like draw it up, you wouldn't have an angle and opposite side together, right? So law of sines can't work. You need something else. So side, 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 and side, angle, side. Okay, and that's the same slide you had the other day. So this is the law of sines. If, for example, I know what side B is, and I know what side C is, and I know the angle in between those is angle A, then I could solve for side A, the little a. And the formula is here, right? And it's actually not A, it's A squared. So you got to remember, sometimes when you solve for it and you forget to take the square root, you're going to be off, right? So you could see the side you can solve for is the side which is across from the angle that you know, right? So A squared equals B squared plus C squared minus 2BC cosine A. And that's just the scenario when you know side B, side C, and angle A. Okay, if it's one of the others, right? If you know side A, side C, and angle B, then you solve for B squared. Or if you know side A, side B, and the angle C, then you could solve for C squared. So it just depends which parts you've got. Okay, then I should say this is specifically, this is the side angle side case. You know two sides and you know the included angle. So you're solved for a side first. Okay. Good. Good. Okay. So let's try this. Solve triangle ABC with those values. Let me get rid of this book. So B is 34 degrees, right? And A is 11, and C is 14. Okay, so what do I have to solve for? I got to solve for the B squared, right? So I'm gonna write the whole formula out the first time, since we haven't used this yet. This will be B squared equals A squared plus C squared minus 2AC times the cosine of B. It's kind of hard to tell the difference between the C and the C of the cosine. Okay, so now I fill in B squared equals A squared is 11 squared plus 14 squared minus 2 times 11 times 14 times the cosine of B, which is 34 degrees. Okay, now that's something you can just put in the calculator exactly, the whole thing. Don't try to chunk it and hit equals and then try to do more, because you can mess it up, when in fact it's something you could put in the calculator just like that. Okay. So what is that one in the back? Oh, that's probably... There, that's better. Turn it on. So just like I see it, 11 squared plus 14 squared minus 2 times 11 times 14 times cosine of 34. Right, just put it all in, we get 61.656. and then you take the square root of both sides. Again, which I'm going to do by doing second square root, second negative sign for answer that brings up that 61.656, and I hit the square root or enter, 7.85. I'll call it 7.9. So there's 7.9. Okay, now we need to solve for one of the angles. How do you think we'll solve for the angles? I mean, you could always use the law of sines, because now we have one angle in opposite side pair. So actually the law of sines would work. For the most part, that's usually the way you do this. You know, use the law of cosines because you have to. And then once you've got one angle in opposite side, you switch to the law of sines. Now, the one angle that we know is an acute angle, right? We don't know if there's an acute angle or an obtuse angle in this triangle. There could be, right? The problem is that if we solve this for any old angle, then we might have to worry about that two triangle situation. What I would recommend is, if there's an obtuse angle, where is it going to be relative to these three sides? Where's the obtuse angle going to be? It's going to be at C. So let's solve for A. A will definitely be an acute angle. And then once we got that, we can just subtract from 180 and we'll get the other one. And we'll find out if it's obtuse that way, not by having to solve the triangle twice, right? So let's use the law of sines to find angle A. So sine A divided by 11 equals sine of 34 divided by 7.9, right? So that means sine A equals 11 times the sine of 34 divided by 7.9, right? So we're going to go 11 sine 34 divided by 7.9, and it looks like 0.7786. And then how do I find, if that's what the sine A equals, how do I find A? You do the inverse. So I'm going to just, in one step, I'll go second, sine inverse, second, answer, enter, 51.1 degrees. So I can fill that one in. And then I can do 180 minus to find the last one. 180 minus 51.1 minus 34. 94.9, which is obtuse. So in fact, that would have been the case. So if we wouldn't have solved for A first, if we would have tried C, we would have gotten an acute angle. Because when you do sine inverse, you'll always get an acute angle. And then we would have done 180 minus to get the angle A. And what you would have found when you filled all this in is you didn't have the biggest side across from the biggest angle and the smallest side across from the smallest angle. That's how you would have known it was wrong. Okay, but in this case, let's see, do we have all those things? Is the biggest side across from the biggest angle the smallest side across from the smallest angle? Yeah, it is. So that's it. I'll write down the C equals 94.9. Okay, so try to do the same thing with this one. Right? Is this it? No. That's not correct. I think you use the sine as a cosine. That's why. That's good. That is good. That 7.5 is correct. But then angle A, that is not correct. Where did you set up the log sign? Okay, well that's not correct either. Sine C over 10 equals sine 48 over 7.5. You might want to check the math. 10 times the sine of 48 over 7.5. And then you do the inverse. Okay, second right. Okay. No, negative. 82 point. Let me see yours again. 52.4. Where are you getting off like that? 8 squared plus 10 squared. 2 times the cosine of 48. Degrees. That's right. So, get the 7.5 correct. You got that right. Sine C over 10. So you get 10 sine 48 over 7.5. That's that. You did sine inverse of that. I'm not quite sure what's going on, why you're so off, because it doesn't seem like it's that close. And it seems like you used all the right numbers. Okay, let's look at this. Start this. So you should have solved for side B and gotten 7.5. That should have been the first part of it. Did everybody get that? 7.5? And then from there, you would have had to solve either for this one or for this one. You know, I solved for A. Again, going for the smaller of the two, because just in case there was an acute angle an obtuse angle involved, I knew this would not be it. And I got 52.4. And then you subtract and you get 79.6 for the two. I'm trying to figure out Haley's that she solved for this. Did anybody else solve for C first? Anybody? Okay. So she solved for C first. She got like 82 point something, and it shouldn't be that off, right? It should be closer than that. I mean, there were some in 1A when we were doing this that, like, when they solved here, I think it's actually like 7.55 or something like that, and they were using that extra decimal place, and that changed the answer some. That changed it to like 80 point something, and that could be explained. But that seems like too much change. But maybe it's not. Maybe that's just what happens if you go for that one first. To me, it should be more. What's that? Okay. And what did you get for an answer? You got 82.2 and not 79.6?
I got them both. I wanted to see what it would do.
So that's interesting. You need to kind of look into that and see why it could be so far off, because it shouldn't be that far off. I mean, one thing for sure is when you're dealing with these sines and cosines, you know, small little changes can make bigger changes in values. But to me, that just seems like it's too much. So when you solve for C, you use law of sines to solve for both of these. And actually, so one time you get 79.6 and one you get 82 points. Okay. All right, I haven't seen that. I'm going to look into that one a little bit more. Anyway, this is the side angle side. We started with a side angle side. We solved for an opposite side. Okay, the other scenario where we use this is when you know three sides. Okay, if you use three sides, and that means you're going to have to solve for an angle first. So you're going to take that same law of cosines that we had on the previous slide, but this time you're going to solve it for the cosine of A. In this case, it's A. So that's the same thing. We just rearranged it so that it's got a cosine of A in one side. And you can see that it's, you've got all three sides, so that's a given. But it's a B squared plus C squared. Those are the two sides that are not across from the angle that you're trying to solve. Whatever's in this position here, that's matching the angle that you're trying to solve for. So of course, you could have three of those, depending on which is the angle that you go for. Right? If you're going for B, for the cosine of B, then it'd be minus B squared. If you're going for the cosine of C, then it's minus C squared. Now, what are all the values that an angle in a triangle could have? What's the range of values that you could have for one angle in a triangle? Say again? Okay, 0 to 180, right? I mean, it could be you could have one angle, which is 179.8, and then have 2.1s. So you can get as high as just less than 180 and still have a triangle. But it's got to be between 0 and 180. Now, just again, going back, just because the unit circle is as good a place to look as any, that means that you could have angles anywhere from here to here. Right? Now, when you use sines, and you have to take the sine inverse, you don't know when you get a value whether or not you're in the first quadrant or the second quadrant, because actually sine has the same values in both of those, right? Sine is the y coordinate, and y is positive here and it's positive here. But cosine is not like that, right? Cosine is the x coordinate. X is positive in that direction, negative in that direction. So you'll know when you're using the law of cosines, when you had to do a cosine inverse, if it's cosine of the angle equals a negative number, you know you're going to get an obtuse angle. If it's cosine equals a positive number, then you're going to get an acute angle, right? So with cosines, it's always clear which quadrant. You don't have this two triangle kind of situation. It has to be like positive, that side, negative, that side. So when you solve, like here, go to the next. So let me label these three. A is 12, B is 27, and C is 20. I mean, the first thing you got to say is, at this point, what angle do I solve for? Because I got all three angles, which side what angle? I've got all three sides. I got to decide then which way do I go? Does it matter? Can I just solve for any of them first? And the answer is, we know that we're going to use the law of cosine to get this first angle. And then we're probably going to switch to the law of sine. And if we use the law of sine, we got that two triangle situation that we kind of like to avoid. Well, we can avoid that situation if we solve for the biggest angle first. Because the biggest angle, if there's an obtuse angle, using the law of cosines, we'll find it. And it won't be ambiguous. We'll know it right away. And then we go to the law of sine, so we find the last two, which have to be acute. So how do I know which one of these angles might be an obtuse angle? it's got to be across from the biggest side, right? So it'd have to be right there. So solve for the biggest angle first. So let me use that version of this alternate form. Now, and I'll write it all out the first time because we didn't see it yet. Cosine of b equals a squared plus b plus c squared minus b squared divided by 2ac. And I fill in for all of that. Cosine of b equals 12 squared plus 20, oh, that's wrong. Plus 20 squared minus 27 squared divided by 2 times 12 times 20. Right, and then bring up the calculator and clear. So 12, I mean, you probably should use parentheses when you do this or something. 12 squared plus 20 squared minus 27 squared, end parentheses divided, start parentheses, 2 times 12 times 20. And in fact, it is a negative number, negative 0.3854. So if the cosine is negative, you know that this is going to be in the second quadrant, negative 0.3854. Again, use the cosine inverse. B equals second cosine inverse, second answer, 112.7. So we got angle B is 112.7. All right, now we got to find angle A and C, and you know what? Doesn't matter at this point which one we do, but you probably want to use law of sine. So let's go. Sine, I'm going to do A first. Sine of A divided by 12 equals the sine of 112.7 divided by 27. So the sine of A equals 12 times the sine of 112.7 divided by 27. So let's number crunch that. I've seen some people do this. You could do this too, right? You can say second sine inverse, and then let's put all that mess in there. 12 times the sine of 112.7, right parenthesis, divided by 27. So all in one step. And it looks like it's 24.2. Okay, and 24.2. Okay, next. Now we got to find C. So again, you could just do 180 minus. So once you do that, I'm gonna use the law of sines and see whether we get the same kind of discrepancy that we had before. So this one would be sine of C equals, what's opposite of C? 20 times sine 112 divided by 27. So C equals second sine inverse 20 times the sine of 112.7 divided by 27. 43.1. What did you get when you did this, the 180 minus? 43.1, so it was exact. Okay. So that's when you've got side, side, side. That's how it works. So try to do that one. It's another side, side, side. What is that? 34. What did I got wrong? I think I must have done something wrong. Oh, yeah. Okay. So that was good. Well, so far so good. 34.1.
Just did the same thing,
Uh-huh.
and I got 85. Oh wait, no, just kidding. I got it.
Okay. That's good. You get it?
Did I get it right?
Yep.
I'm going to make sure that I get my homework as soon as possible. So,
What's that?
I'm going to make sure I get my homework.
Okay. So let's say a cosine b, you still got to find b. You got to do cosine inverse to find the actual b, right? Oh, you did put it. Oh, okay, you're right. Sorry about that. Okay. So most seem like you're getting it. Right? So you had to solve for cosine of b and then take the cosine inverse, 85.2, and then you had to take your pick on a or c to find next. I got 60.7 for a and 34.1 for c. Right? So that's law of cosines. The two possibilities, right? Side angle side and side side. Now there's one more thing we're going to do here. First we're going to do a word problem. Right? So scientists use a set of footprints to calculate an organism's step angle, which is a measure of walking efficiency. The closer the step angle is to 180, the more efficiently the organism walked. The diagram at the right shows a set of footprints for a dinosaur. Find the step angle B. All right. So do we have enough information to find the step angle B? Yeah, it's a side scenario, so you can go right away to the cosine of B equals 155 squared plus 197 squared minus 316 squared divided by 2 times 155 times 197. And clear that. So let's go parentheses 155 squared plus 197 squared minus 316 squared and parentheses divided 2 times 155 times 197. So it's negative, which you kind of expect. It looks like we're expecting a obtuse angle here. And second cosine inverse, second answer, 127.3. So the step angle is 127.3. Is that good? Who knows? It says they'd like it to be closer to 180. I mean, you could see what's going on, the footsteps. It's like if you're walking along with, feet this far apart, if you're doing a lot of side-to-side movement, then your angle wouldn't be as great, But if you're mostly kind of like putting one foot in front of the other, then that angle is going to be closer to 180. So, I never heard of a step angle before. Okay, last thing. Okay, we have another formula for the area of a triangle. So we learned one last class that involved the sine, and we already knew one, which is 1/2 the base times the height. Here's a new one, which is called Heron's area formula. And you can see that inside the square root of the formula, there's the A, B, and C, which we recognize. Those would be in side lengths. But there's also an S. And S is defined as 1/2 A plus B plus C. And when you add up the A plus the B plus the C of a triangle, what is that called? It's the perimeter, right? This is not the perimeter. It's half of the perimeter, right? Called the semi-perimeter or half perimeter. Okay, has everybody got that? Simple little formula there, Hannah? Good. Good. Okay, so let's do an example. This one says, urban planning. The intersection of 3 streets forms a piece of land called a traffic triangle. Find the area of the traffic triangle shown. Okay. I mean, I could see that being a practical problem for somebody who had to like plant grass seed or something like that, and they needed to know, you know, like how much, usually it's in square footage. It's an area that you need. So if you just know the length of those streets, you could plug it in and figure it out. So let's see, what's the first thing I have to calculate? I need to calculate S. So S should be the A plus B plus C over 2. So 170 plus 240 plus 350 divided by 2. And what is that? 380? 380. Okay, so then we go right to our formula. The area equals the square root of 380 times 380 minus 170 times 380 minus 240 times 380 minus 350. So area equals so just plug it in 18307.4. 18307.4. Do we all get the same thing? Okay. So do one more you try and that's the end. Right there. Find the area of the triangle. So what did you get to be S? In the area? Okay. I agree. Right. It's a pretty easy formula to use. Okay. So that is the end. So you might want to copy that down so after the quiz you can work on it, because the quiz probably won't take it that long.